Let's talk about one of the subtopics within cone called as frustum of the cone. I just kind of have hard time pronouncing this sometimes. I say it's frustum, but anyway, it's frustum. Okay. First, let's understand what a frustum even means. And the typical example is you visualize in your head a lamp shade, a night lamp or a study lamp. It's not a study lamp, but a desk lamp, or it's pretty much a night lamp for the showpiece. And this kind of the top view of that, and this kind of the geometric view of that, which is kind of an odd shape, right? That is nothing but this shape is a frustum, okay? And how it is formed basically. So it's, if you take a simple cone that we have covered in the previous topic, okay, if you take a simple cone and if you just chop it in between, straight slice it out without parallel to the ground, you take a blade or razor and slice it up, okay? So what happens is this original cone gets split into two parts. One is a smaller cone and one is a odd shape, which is the frustum. So that's how you get a frustum. So you take a larger cone, slice it in the middle parallel to the ground. That splits into two parts, a smaller cone and a frustum, and that's how you get it. So that's the combination of that, and you can see that from this visuals, or I put additional visuals also for you to understand how it works. If you see a larger cone and then chopped, and you get this, okay? And if you want to visualize inside a single cone, that means this cone, if you see all these visuals inside one picture, you will see there is a larger cone in blue. This blue is larger cone, and this orange over here is smaller cone. And if you imagine that there's a split here, whatever you get here, this shape becomes the frustum. So it's all combined together. You can visualize it that way also, if that helps. So that's frustum. Now the question is, how do you calculate the volume of this frustum, which is kind of an odd shape? And since we have kind of got into this intuition of chopping and splitting into two cones, or chopping a cone and getting a smaller cone, and that notion, we can use that notion to calculate the volume of the frustum. For example, if this particular cone is chopped into this and this, if you just focus on this part here, okay, so I'm getting a frustum at the bottom, okay. So we want to calculate the volume of this piece, right? We want to calculate what is the volume of this frustum. That's what we want to calculate. But we know that the volume of this, let's say this is V1 and this is V2. This V1 plus V2, this both the volumes, the volume of the smaller cone and the volume of the frustum, is going to be equal to the volume of the bigger cone, the larger cone. We know that, right? So in that case, since we already have the formula that we have seen earlier to calculate the volume of cones, we can use that formula. So we can take the volume of a larger cone, this piece here, and subtract the volume of the smaller cone, this piece here, to give us the volume of the frustum, right? So let me just put it back here. Let me just erase it and explain it again, because it's easy that way. Okay, so what I'm going to do, if you see in blue here, I'm going to take the volume of the larger cone, this whole cone, okay, from here to here, the whole cone. I'm going to take that cone, the volume of that. I'm going to subtract the volume of the smaller cone, this piece in orange color, I've highlighted in orange, or in this piece, right? So this two volumes, I'm going to volume of larger minus volume of smaller cone, so larger cone and smaller cone. So I'm going to take this to get the volume of this, okay? That's what I'm going to do. So let's take how to do that. It's very simple, okay? Now we are going to find the volume of a frustum based on the above intuition. So let's take this particular figure or schematic, okay? So, and we know that we're going to take the difference of the two cones. The difference of the bigger cone, which is from this point, these 3 points, okay? That's a bigger cone. We know that the formula given by that is going to be 1/3 the pi r square h. And if you remember, this pi r square h by itself is the volume of the cylinder, because volume of any cone is 1/3 the volume of a cylinder formed by, if you inscribe the cone inside the cylinder. We have seen that. That's an easy way to remember that. If you put a cone inside a cylinder, sorry for the diagram, so that's how the volume is calculated. So volume of any cone is equal to 1/3 the volume of the cylinder in which it is inscribed or dipped in. So we get the larger cone that way easily, because we have the capital R, which is the radius of the base at the bottom, and we have this capital H, which is the height of the overall larger cone. We have that from this point to this point exactly perpendicular. That's the height. Now we need to subtract the volume of the smaller cone. And how do we calculate the volume of the smaller cone? Let me get rid of all these things so that we understand where the smaller cone is. The smaller cone is starting from here. Let me erase this also. Okay. So if I slice it from here, this is my slicing point, okay, all the way like this, okay. If I slice it here, then this cone that is formed, that is the volume of that is my smaller cone, and I need to calculate the volume of that and subtract it so that I can get the volume of the remainder. And the volume of the cone is still going to be the same. It's going to be 1/3 pi r square. Now the r square is going to be this r, the smaller r, not this r. That's why we have put a small here. So this is a smaller r. So we're going to take this raise because this is also going to form a circle at the bottom after it is sliced. So that r, and we need the height. Now how do we calculate the height of the smaller cone from this point to this point? Okay, how do we calculate that? We don't have it. But since we're going to chop and we can calculate the height of the frustum, if the volume of this cone is not given, what we can do is, if we know the height of this frustum, we can take the difference of these two heights, the volume of the bigger cone, the larger cone, and the volume of the frustum, and that will give us the volume, this height that we are looking for, right? This height minus this height. So this h capital minus small h, these two things, if I subtract, I'm going to get this particular height, whatever is the height from here, the exact perpendicular height, this height. Okay, let me just, what is the height I'm going to get? What is the height I'm looking for? This height from here to here, this height. This is the height I want. And I can get using the difference of the two heights. Okay, and that's what I'm taking it here in the exam. One of the things will be given to you. If it's not given, this is how you derive. And when I subtract whatever I get in terms of cubic units, that is going to be the volume of my frustum that I've calculated. The volume of this piece, the frustum, is going to be calculated or computed using that particular formula. And there is a derivation of how to simplify this and how this comes. I'm going to put another topic for that in case you're interested, but that may not be relevant for the exam, because as long as you remember, it's just a simplification, but as long as you remember that's a difference of a larger cone minus smaller cone, you should be good to go, and you can calculate that solution easily using this formula. So let's focus on that. If you're interested, you can check out the next episode or next topic on the derivation itself.